Welcome to our lesson on functions. So this is our section where we actually introduce the functions, and we're going to talk about some various terms that apply to what functions are. But before we learn about a function, there's something else that we have to learn about, and that is a relation, okay? So what is a relation? A relation is a set of any, and I want to underscore any, ordered pairs, okay? So we can have a group of ordered pairs and in that, you really can see where there's probably not going to be an equation that these ordered pairs would satisfy. It's just a random collection. Now, it could be something applicable to a line, but so a relation covers any set of ordered pairs, okay? So a function, then, couple of things. A function is a relation, all right? But more importantly, a function is a set of ordered pairs where each input has exactly one output, okay? So basically, when I take an input value and I put it into my function, whatever that is, here's my input, I know that what's going to come out is the same output every time, okay? And what's important about that, not only is it the same, but is the same unique output, okay? So when I put it in, I know that I'm always going to get the exact same thing out. So let's look at a group of these, okay? If I had 2, 1, minus 3, 6, now I'm looking at very similar to what I had up above. Now let's say I repeat 2, okay? In order for it to be a function, I have to get this 1 every single time, okay? If I did this with a relation, who knows what I might get, okay? So this 2 produces a 1 and a minus 12. Therefore, it's a relation. The function, every time I have a 2, it's going to produce a 1, okay? Now, there's a couple of terms that we can think of related to all of this, and input is also going to be known as the independent variable, okay? So when we have an input, what's going in is independent of the actual function itself. What comes out is the dependent variable, and it's dependent because this output depends on this input, okay? So input independent, output dependent, and it's dependent because it depends upon what is going in, okay? So another way of saying that is a function is a set of ordered pairs in which no two ordered pairs have the same first coordinate and a different second coordinate, okay? Same first coordinate, different second. Therefore, it's a relation. Same first coordinate, same second coordinate, okay? So just some terminology there. Now, something else we want to look at is there are some other terms here. This 2 is a member of the domain, okay? This 1 is a member of the range. These are collections of independent, dependent, or input, output, however you want to talk about it, okay? But really, the domain is the set of all, important word here, valid inputs, okay? And then the range is the set of all outputs from the domain, okay? So I can't have a member in the range unless it was produced by the domain, all right? So let's look at this one right here. My domain for this problem is the set of valid inputs, all right? So I would have a 2, a -3, a -10, and a 2 again, okay? And I don't even have to really write that a second time. The range would be the outputs, right? So I have a 1, a 6, a 1, and a 1, all right? Now there's something really important to notice here. I can have 2 different inputs produce the same output. That does not disqualify it. Remember, it boils down to when I have this input, it has to produce the same output every time it occurs, okay? So all of these inputs could have produced 1. That's okay, but they can't produce a different output when I have the same input, okay? So how would that look maybe on a graph? Just real quick. So if I had a 3, 1, a 0, -1, a 2, 3, and a -4, 1. And I graphed all of those points. So over 3, 1, over 0, -1, over 2, up 3, and -4, 1, okay? So each one of these inputs, it doesn't matter. It's okay that they have the same output. This is still a function. But if I had this point over 3, up 2, I would have in line here 2 outputs for the same input. And when you think about an equation, how can you have a number going into something that produces 2 different numbers going out, okay? So just to give you a little bit of a picture of what I'm talking about there. Okay, so that gets us through domains, ranges, but we have to be able to calculate a domain, okay? So how do we do that? Because remember, the domain is the set of valid inputs. So when I'm looking at that, what am I talking about? Well, things that make an equation invalid. Well, one of those is a divide by 0, okay? And the other is the square root of a negative number. So when I'm looking at my equations, I need to look at them and make sure none of that is actually going on, all right? So if I have my function f of x, right, f of x, and I say it is equal to 3 over x plus 2, all right? And I want to calculate my domain there. What numbers going in are valid for this function? That's what I'm asking myself. Well, I'm not going to have any, there's no square roots here, so I don't even have to worry about it. But I've got a denominator here. So I have to make sure this denominator is never 0. Well, how do I do that? Well, let's go figure out what values make it 0, okay? So if I set the denominator to 0, and then I solve for that x value, that makes it 0. So if I put an x equals minus 2 into here, I'm going to get a divide by 0. So I know that x cannot be part of the domain because it does not produce a valid output. So my domain here becomes all, and then we'll use this symbol to represent real numbers. So all real numbers, x not equal to minus 2, all right? So calculating the domain, set the denominator equal to 0, solve for the value that makes it 0, and then exclude it from your domain, okay? So that's obviously something we got to worry about. Let's look at another one. F of x is equal to 3x over x squared plus 6x plus 5, okay? Now, it's okay for a value to exist in the numerator. That doesn't bother my domain calculation, okay? So if I put a 0 in for x, that's okay because it doesn't cause a divide by 0 and it doesn't cause the square root of a negative number. But what's my rule? Set the denominator equal to 0. So x squared plus 6x plus 5 equals 0, and then solve. Well, how can I solve? This guy can be factored into two binomials. My signs are the same, they're both positive. I need something that'll produce an x squared. Well, that's going to be x, and then factors of 5 that add to 6 are going to be 5 and 1. Okay, so my zero product principle tells me if this binomial is 0, my equation is true. If this binomial is 0, my equation is true. So again, I just solve for each of the binomials equal to 0. And when I do that, I get x equals minus 5 and x equals minus 1. So these are the values that when they're input into my function make 0 in the denominator, which of course I can't have. So my domain then becomes all real numbers, x not equal to minus 5 or minus 1, okay? So that's how you go about calculating a domain here where we're talking about divide by zeros, okay? And you would do the same thing if you had a radical. You just have to make sure that you don't ever get a negative number underneath that radical. So if I had f of x was equal to the square root of, let's say, x plus 4, okay? So I need values of x that would make this negative, okay? So if I plug in a 0, I'm okay. A -1, I'm okay. Even down to a -4, right? Because -4 plus 4 is 0, and that's all right. But when I look at this, if I go just to the left of the -4 on my number line, okay? Say I had a number line here. 0, 1, 2, 3, -4, and of course these are all positive up here. See, all of these values still leave a positive number, but as soon as I get less than this -4, everything out here is going to produce a negative number. So x less than -4 is the problem I'm worried about, right? So here my domain becomes all real numbers x greater than or equal to -4, okay? So if it's less than -4, I get a negative number, right? Because I'm looking for a value x plus 4, right? That's going to be less than 0 because that's my negative, okay? I subtract 4 from both sides and I get that -4. So this makes it invalid. This, in turn, makes it a valid statement. Anything greater than or equal to -4 is not going to cause a problem, okay? So now if my radical happens to be in the denominator, I still have to make sure I don't have a negative, but then I also have to make sure I don't end up with a 0 in that radical as well, okay? So what did we learn today? Well, we learned about domains and ranges, valid input producing valid output. We learned about relations and functions. A relation is any set of ordered pairs, and a function is that equation, that relationship that produces exactly the same output anytime I have a specific input, okay? And then, of course, we learned about calculating the domain of a function, all right? So that concludes this lesson, and I will see you guys next time.